Um, Good morning, Mr. Shaw.
Good morning, Victoria.
Sorry I came in late, but what are we doing?
So can you see the 13 problems on the screen?
Yeah.
Okay, so that we're about to go over these. People have just been kind of reviewing on their own. So we're starting a little bit of review for the final exam.
Okay.
Okay. Um, so you get another chance to try these on tonight's homework. Different set of them. But we're about to go over them in 1 minute. All right. Why don't we start going over these? So all of these are considered problems that you should be able to get in a very small amount of time. So if these are taking you a while, you know, when class is over, you get a couple of you got a good month before school starts after class is over. Maybe if you aren't fast at these, you can practice, these and make sure your values for the pi over 6, pi over 4, pi over 3. Just kind of keep those fresh in your head, and that'll assist you a lot going into next year. Although I've noticed, people on the test seem to not have trouble with these. But all right, so 3 pi over 2, you want to locate it. If the denominator is 2, we know it's a quadrantal angle and it's on the y-axis. 3 pi over 2 sits down here at 0, -1 on the unit circle. And sine of the angle is the y value. It's -1. And I said I was going to call around the room, and I didn't do that. So, Elizabeth, do you have an answer on number 2? If so, what'd you get?
I don't.
Okay. Did you sketch it yet? What quadrant is 7 pi over 6 in?
So it's going to be on the second quadrant.
Well, the third quadrant, actually. So first of all, when I see a multiple of pi over 6 and cosine, I'm already thinking root 3 over 2. I just need to know if it's positive or negative. Here's 0. I'm going this way. Halfway around is 1 pi, 6 pi over 6. So 7 pi over 6 is down here. All right. And I'm on the left side of the axis, so cosine is negative. All right. I'm in the quadrant where only tangent is positive. All right, Ramon, how about number 3? Did you get a value for that?
Oh, I just saw the negative sign right now. Because I said, let's see. I was thinking of the third quadrant, but then I see the negative now, so it can't be.
Well, actually, you're correct about third quadrant because it's a negative
angle.
angle.
Yeah, it's a negative. It goes, yeah. So it's gonna be, what was it? -5 pi over 4.
Well, so look, -3 pi over 4 is coterminal with +5 pi over 4. But what's the value here? If the reference angle is pi over 4,
it's going to be negative pi over 2. Negative square root of 2 over 2.
All right, so sine and cosine, you have the right value. But for tangent, if your reference angle is pi over 4, it's 1. And I'm down here in the quadrant where only tangent is positive, right? All students take calculus, so it's +1.
Okay.
Okay. All right, Brian, did you get an answer for number 4? If so, what'd you get? All right, Chiruza, are you back with us? All right, how about Mata? Did you get an answer for number 4?
Yeah, I got the 0 degree or like.
Yeah, it's coterminal with 0 radians. Yep, we're right here. 6 pi is right here. What would the coordinates be right here on the unit circle? What comma what? It's 0 comma 1 or 1 comma 0.
0 comma 1.
Well, don't forget.
I mean, 1 comma.
Yep, x has to come first, just like in the alphabet. Yep. And which one of those numbers is the cosine, the x or the y?
The y.
So look, try to remember it's alphabetical.
Yeah.
Cosine comes before sine in the alphabet. X comes before y in the alphabet. Cosine is the x coordinate, so the cosine of 6 pi is 1. All right, so good thing we're doing this review. All right, Nina, did you get an answer for number 5?
Yeah. I think I did it wrong though, because I got like a degree.
Okay, well,
yeah.
Let's start off with what 2 quadrants can tangent be positive in?
I think the third one.
Yep, and
the first one.
The first one, right? And so what's the reference angle if the tangent has a value of √3? Are we talking a reference angle of pi over 6, pi over 4, or pi over 3? Do you remember?
Pi over 3.
Good. So pi over 3. And, you know, if we were going to give all answers between 0 and 2 pi, I'd say pi over 3 and 4 pi over 3. But to give all solutions, since these are exactly pi radians apart from each other, remember with tangent, you can just give one answer and just put plus k pi. Pi over 3 plus any multiple of pi. And somewhere you want to make note that k represents any integer. All right. Mark, how about you? Did you get an answer for number 6?
Yeah.
Would you
I got 3 pi over 4 and 5 pi over 4.
Okay, yep, plus any multiple of 2 pi. So our reference angle is pi over 4. Cosine is negative anywhere on the left side of the coordinate plane, anywhere where x is negative, right? So here's 4 pi over 4. That makes this 3 pi over 4 and this 5 pi over 4. So 3 pi over 4 plus any multiple of 2 pi and 5 pi over 4 plus any multiple of 2 pi. All right. Jocelyn, did you have an answer for number 7? And if so, what'd you get? All right. Let's see if we can help her out here. What quadrants can we be in if tangent's positive?
The first one and the third one.
Right, first one and the third one, just like number 5. So I really just have to, and they're pi radians away from each other, so I can just give one of them and say plus k pi. What's my reference angle?
Pi over 4.
Good, pi over 4. So pi over 4 plus any multiple of pi. All right, how about this last one? What 2 quadrants can I be in if sine is negative?
Cool, lower it.
The third one and the fourth one.
Good. Yep. The third one and the fourth one. And my reference angle is pi over 3. Here's 0. Here's 1 pi. So as a positive angle, this is 4 pi over 3. As a positive angle, this is 5 pi over 3, but I can also call it negative pi over 3 if I want to. All right. And I could also call this one on the third quadrant negative 2 pi over 3 if I wanted to. Negative pi over 3 plus any multiple of 2 pi, and 4 pi over 3 plus any multiple of 2 pi. That's my complete set of solutions to that equation. Any questions? Yeah, please.
I just wanted to ask, would you expect the students to say like k equals 0, 1, 2, 3, or k equals minus 1? I mean, they have to say what k is?
Yeah, no, so at some point on a written test, I would expect them to write somewhere that k represents any integer.
Okay.
Okay.
I missed that. Thank you.
Thank you. Any other questions or clarification needed on those first 8 problems? All right. Well, these next couple of questions seemed like a strength for people based on the last test. Elizabeth, what'd you get for number 9 as a final answer, and then we'll talk about the steps I'd want to see.
48.
48, right? Not, you didn't say ln 48, did you? Just 48.
Yeah, I can.
And this was really the same question on the test, except the ln 3 and 2 ln of 4 were surround. But what I would want to see as steps, e to the ln of 3 plus ln of 16, showing you know the 2 came on the 4 as an exponent, equals e to the ln of 48, and then equals 48. All right. Ramon, did you get an answer for number 10?
Yeah, I got natural log of 4.
Right. So, and steps would look like this. The 2 comes on the 10 as an exponent. The 2 comes on the 5 as an exponent. So you could say natural log of 100 minus natural log of 25. And then natural log of 4 would be your final answer. All right. And Victoria, I know you just jumped in, but do you remember this one? 3 to the what gives you 1 over 27?
3 to the negative 10 root 7.
Good. 3 to the negative 3. And that's all this is asking. 3 to the what power gives me 1 over 27. Brian, are you there?
Yeah.
Okay. How about number 12? 5 to the what gives me the...
2 over 3.
Good. This is 5 to the 2/3, because it's the third root of 5 to the 2. And how about anybody on this one? How do we want to, if we're expected to use this given information, I mean, on the calculator, I could just do log of 56 divided by log of 2 and come straight to the answer. But on this type of question, you'd have to show me where does it come from. How do I want to rewrite the log base 2 of 56, anybody, so that I can do this problem without a calculator? Anybody?
Log base 2 of 8 plus log base 2 of 7.
Exactly. I want to think of this as 8 times 7. And this would be okay to just show this for your first step. And so why can we do this without a calculator? Because I know 2 to the 3rd gives me 8. And they told me 2 to the 2.807 gives me 7. And then my final answer would be 5.807. All right. So I did with this for anybody that needs to look at it again. But you'll have some questions similar to this on your final exam. So make sure part of your homework for the week is make sure you're ready for that. And you'll have a little more review of this page and then a little review of what comes next as part of your homework tonight. But I wanted to switch gears and give you guys a little preview into some open response AP questions. All right, and I have written on all of them what year and what test these questions came from. So these are all actual problems, just modified to take out anything that needs calculus to solve. There's plenty of questions. Well, there's occasional questions where you don't need calculus to solve them, and some people don't see the other way to solve it sometimes, and they spend too much time. But what I like to do is, this is your first time seeing anything like this. A graphing calculator will help for some of it, but I like to split you up into breakout rooms and have you just do your best. Please talk to each other. What would be nice is to pick a spokesperson from your group. So when we come back, I'm going to ask who's the spokesperson for group 1, who's the spokesperson for group 2, and I'm going to talk to that person and see if your group was able to make sense of any of these questions. All right, let's shoot for 25 minutes, and if you guys are completely lost or anything, get in touch with me. I won't make you sit 25 minutes if you're out of ideas, but I guess I will stay in the main room so you can pop back and ask me questions if you are feeling totally lost. And I think 25 minutes should probably be a good amount of time before we come together and talk to these. Mr. Tapia, are you around for the next 20-25 minutes? Should I make you as a go-to person in one of the groups, or are you just popping in and popping out?
I can sit for a bit. That was going to be the plan, so yeah, I can help out.
Excellent. All right, great. So let's do two.
How much do we just do, like A, B, C, D, and that's it?
Oh, I'm sorry. So thank you. I already emailed it to you. So open it up in your email and see how you go. See how it goes. Why don't we? Okay. All right. I'm gonna stop the screen share. Let's do some breakout rooms. Let's do 3 breakout rooms. One group will have Mr. Kaplan, one group will have Mr. Tapia, and one group will have just an extra student. So you'll have a little more brain power. But you can all pop back into the main room and ask me for clarification on anything. Let me just see if I need to. Nope, this works out. So group 1 will have Mr. Kaplan, group 2 will have Mr. Tapia, and group 3 will just have an extra person in there. And Mr. Tapia, would you like me to email you the paper as well? I know you're familiar with this one, but should I email it to you?
I have it. I'm good.
Okay, cool.
You gave them to me a while ago. I love these.
Okay, awesome. Hello, Ariana. Ariana, are you there? Hello, Ariana. I can't hear you. Can you hear me?
Hello?
Hello.
Sorry.
How are you?
I'm okay. I had to do something. Sorry. I'm
Okay.
so late.
All right. I'm gonna. I sent a file to your email, and I'm going to put you in breakout room number 3.
Okay.
You have the most kids in there, and you guys are supposed to elect a spokesperson and think about these problems together. They're based on an actual AP open response problem, and I just want you to see what you guys will come up with. Okay?
Okay.
Be in there.
I had a question.
Yeah.
I wasn't able to see my test score on the Edulastic thing.
Really? You logged in and weren't able to see it?
Yeah.
You had a 84 plus 8 points. That's 92. But
Thank you.
try that again later. See if.
I will.
Okay. All right. So I'm gonna throw you in breakout room 3.
Okay.
Okay. Are you still here?
I must end it. Oh, 5.142.
It approximated your answer already. We got 5 also, 5.08.
Mm-hmm.
Yeah, you're close.
All right. Hey, glad to hear you guys discussing stuff in here. Anybody have any questions before I pop back out?
No, yeah.
Okay. All right. I'm glad to hear you guys are doing what I asked you to and talking to each other. I'm going to pop back in the main room for anybody who's looking for me.
Bye, Mr. Shin.
All right, Chiruza, have a good day.
Yeah, you too.
Thanks.
Oh, I wanted to review the other number 2 of the homework.
Mm-hmm.
I don't know if you can send me a little bit a video of showing the way how to do it, because I tried, but
Tell you what, have you got a chance to look over the answer key yet?
Not yet.
So tell you what, why don't you tonight look over the answer key? That'll probably help you understand some of it. And then are you able to log on like 10 minutes early tomorrow?
Yeah, I can be. Even in fact, I always wake up at 6, so by 7 I'm always here.
Okay, I won't be able to get on much earlier than 7:50, just because I'm usually getting my boys feeding them breakfast at that time. But I'll make sure I'm on at least 10 minutes early tomorrow if you want to be ready.
Yeah, yes, sir.
Excellent. All right, Chiruza.
All right, thank you.
Have a great day.
Yeah, you too.
Thanks. Bye-bye. Let's see. Hey, well, I think this is a good sign that nobody jumped right in right away. So you guys must have still been talking. That's that's a good sign. All right, so let me do a screen share here, and I'm going to share my desktop between open board and online calculator. All right, so who is my spokesperson from group 1? Did we pick one?
Hey, Mr. Sheen, I just wanted to report my group did great, and I am going to take off now.
All right, thanks. Thanks for the help.
Yeah, I enjoyed it.
All right.
I love those questions.
Yeah, appreciate your help. Have a good day.
Yeah, you too. Hopefully I'll be able to check back in later.
Sounds excellent. So you guys didn't pick a spokesperson in group 1?
Was that Mr. Tapia's group?
No, that's group 2. So are you the spokesperson from Mr. Tapia's group?
Yes.
All right, beautiful. Mr. Kaplan, who do you think should be the spokesperson from your group?
Oh, Mr. Kaplan.
Mr. Kaplan, are you there?
It just said that he left.
Oh, okay. How about group 3? Do we have a spokesperson from group 3?
That's obvious. I think
Okay.
that's
Okay. All right, let's see. Here's Mr. Kaplan. All right. Hello, Mr. Kaplan.
Well, I couldn't hear you, so I checked out and then signed back in.
Okay. Hey, who should I pick as the spokesperson from group 1, Mr. Kaplan? Who do you think?
Okay.
It's me.
Yeah.
Oh, Victoria?
Right,
Yeah.
and Ramon and I will help if necessary.
Beautiful. All right, beautiful. Thanks. So Victoria, what did you get for answer number 1? What'd you get for a value, and how did you explain it?
We got 5.086.
Beautiful. 5.086. 0.086. And what does this mean?
We said it means that in 3 hours, the rate at which the water drops is 5.086 cubic feet per meter.
Yeah, beautiful. Almost 100% right on. But let's say at t equals 3, right? Hours. Now, R of t represents water coming into the drain pipe, right? So water is entering the drain pipe at the rate of 5.086. And what did you say were the units?
Cubic feet per meter. Cubic feet.
Per hour, right?
Yeah.
Beautiful. Beautiful. And if I was all right, so that's a rock solid answer for an AP question. If I was writing it, I would just write, I would write cubic feet per hour like that. But in text, it's like that. Nice job. So Mata, what did you guys get for part B? What's the value of D of 3?
Value of D of 3 was 5.4.
Good, 5.4. And how would you explain that? Because a lot of these questions, you'll get like 1 point for the number and 2 points for the explanation, or sometimes you get no points unless you get the number and the explanation correct. So how did you explain that, Mata?
Said water drains out of the pipe at 5.4 cubic feet at 3 hours.
Beautiful. Yep. You want to mention X and Y. Beautiful. So the way you said it is fine, but I'm just going to write it in a manner consistent with, but yeah, you would get full credit for that. So water is leaving the pipe at the rate, and I get PPE, pipe, of 5.4 cubic feet per hour. Beautiful. All right, and I'm gonna show you some stuff in a minute, but let me call on Mark. So what's a good answer for number 3, Mark? Is the total amount of water in the pipe increasing or decreasing at time t equals 3?
It's decreasing because the water is flowing out of the pipe at a faster rate than it's entering.
Beautiful. It's decreasing. And here's, if you were going to explain to a person in the room, that's the way I would say it. If you want your calculus answer, the answer that's going to get you, make sure you get credit, you would say at t equals 3, D of 3 is greater than R of 3. Okay? And then if you want to, include a verbal description, water is leaving the pipe faster than it's entering. That's fine too, but you're going to need that D of 3 is greater than R of 3. That's your mathematical argument on there. I'm going to show you guys some stuff on the calculator. If you don't know how to do some of the stuff I'm teaching you today, then you could probably consider some of the stuff that we'll show you today as, even though it won't be on the final, is possibly even more important than whatever else we've been spending our time on. And I'll show you what I mean. So if you don't have it, A4 email, there's a little version that works here. There's a file, so you can look at your own time. Wouldn't encourage you to try to mess with it now. If you put to y equals, so I click this button, right, and I'm gonna clear it's in y1, y2. So AP Calculus always be in radian mode. Any trigadians, and I'm sorry I missed your question until you were on in the breakout room. Everything's always in radian calculus. No. So 20 sine, it'll treat t, always convert everything to air divided by 35. I have to close the brackets, but I missed the divided by. Okay, now in 2. Okay, so negative, and you got to use bottom key for negative. No, that 0.4 third plus 0.4 x squared plus 0.90 x. All right, I have function in as y, second function in as u. Now I'm going to hit to get out of here. If you didn't know how to this is something that you'll find useful from this button stands for variables. If you hit variables, y variables mean the right arrow, so vars right arrow, and now I want to pick a function. I'm going to pick y1 and I'm 3, just like rotation. This first answer. Plug a number into y, vars right arrow. Now I pick number 2 for y2, and I plug in and I hit enter. Like me to go back that. Okay, let's go back. The problem in it. Okay, so to sketch these graphs on the same axes, Victoria, were you guys able to sketch the graph? And if so,
No.
What's that?
No.
All right, how about Mata? Did your group come up with a sketch that you're aware of?
I have it on my calculator, but I did not draw it out.
Yeah, can you describe the look of it?
Okay, it's a little weird.
Like, what does R of t look like? Is it increasing, decreasing?
It's increasing.
Yep, until the end it starts decreasing, right?
Yes, until the end.
And then D of 3, what is that doing? Increasing or decreasing?
It's increasing as well, but it's definitely lower than the other one.
Right. Okay, but it does intersect. One of them's higher, and then the other one becomes higher. So I'm going to go back to the graphing calculator. This is important in a problem like so. First of all, we notice we're only concerned about the interval from 0 to 8. All right.
Yeah.
Almost all the time on AP problem, they give you a domain. So when you're trying to get a graph, they don't ask graph, but you're going to need a lot of questions. First thing, second window. See how it says table at 0 by 1s. 2 functions in y graph. It says table. I'm going to hit save, and I'm just going to look at the ones that I have. All right, in the left 17, and the right call this number. No negative. I'm going to scroll down. T equals 8. All right. Well, line function, 20 in front. Get any higher than 20, and it won't more than negative 20. The t squared in there, I'm actually not even period, but we still know this to know that it can't be 20 and can't go negative 20. And it looks like the highest it gets less than 13. So I'm going to use that I'm going to go into window 0 to 8. So I'm going to count by 1s, and then I didn't have any numbers, so I'm going to go 0 to 20. And now I'm going to hit, all right, and this, the first one, this is water pipe, and they're leaving them. All right, so it's a way to just see what you need to see, able to help you trying to mess around and playing with and zoom out. So if somebody had asked you to sketch a graph, what would they be looking for? Well, let's put some values on here. This is cubic feet per hour. This is hours. The first function, R of t, looked like this. Went all pretty much to here, and then let's label this R of t, and then D of t looked like this. It seemed to also possibly start off at 0, 0. In fact, it did, looking at the equation. And here's D of t. All right, so we can see. Well, first of all, at t equals 3, D was higher than R. Right? So t equals 3 must have been around here, right, before the two graphs intersected. So at first, water's exiting the pipe faster than it's entering the pipe, but then after a certain point, water is entering the pipe faster than it's leaving the pipe. Group 3, did you guys get an intersection point for this?
I didn't.
How about group? Okay. Did anybody in group 3 get an intersection point? How about group 1 or group 2? Anybody? All right. Well, let's do this together then. If you've been keeping up TI graph, this is a redo. Is find an inter on your calculator. All right. So we have the graph. I can see it's my x scale. So this is 1, 3, 4. But I need to know, and I need to be accurate in decimal places. Above the trait, a lot of important stuff in the second. One thing I can do, let me show graph, pick value, and x equals 3. It shows me which it's now. If I hit it'll switch off, and 4. I can press up 0.086 value from graphing screen. I'm gonna go back to seconds. Z. If you want to find where it crosses the x-axis, which is something you want quite a bit, you're going to pick the function. We'll learn that this week. A minimum, you can find a maximum or a relative, but with intersection. So I'm going to pick number. Use the arrow and hit enter button 5. So it's second trace 5, and this second curve, it's not like it's asking. This is in case there are functions graphed. It's select the ones I want to. But I look up here, line of x squared over 30. Yes, that's one of the functions. So I hit enter. Second curve, this one, I'd use the upper, select the one that I want. Yes, this is the other one. Hit enter, and then guess. Right? When I've got one of these calculated, why are they playing again with me? You know, I wouldn't be asking if I answer. The purpose of it is, if there's more than one intersect, you want to steer in the direction of one you. So if I can sound x equals 3 and around x equals 10, I'm going to type in 3 or type in picks the correct one. I'm going to near it. I can just hit, or I can type in 3. It's probably 3.272 or 371. Either one of those answers would be accepted. Does anybody want me to that intersection again?
Please.
All right. First step, is have your functions set good, use the table, and then have. Do you have all that? Would you like me to?
I have all that.
Oh, second piece. Then you want to pick 5. Now, when it says first curve up top, and that's what your work, you hit enter. And then when it says second up top, the equation is correct. Enter. And then when it says guess, if you're already near the correct enter, you enter. You can use the left and right to get it close to there. I can, if my curve, I left or right arrows and near the intersection, and just hit enter and type in a value. I'm this time. By the way. Okay, so basically on this one, it's just sex, pick number, hit enter, and intersection, x value, and the y.
Yep.
Okay.
I got it.
Next, so 3 and 2, we'll call it. At 3.272, and it's always a good idea to include units. 3.272 hours. All right. So, and if, by the way, if you were going to use that value in another, you would go to your main screen. All right. And even x still got that value. I store that as alpha a. And then anytime I want that value, I wouldn't type 0.272 or 0.271. I would just, and all my accuracy that the calculator has to offer. So does anybody think they can answer this question now? When on this interval, which means 0 to 8, is the total amount of water in the drain pipe increasing? Can anybody give me an interval that the water in the pipe is increasing on? From when to when?
From 3.272 to 8.
You got it. Yep. On the interval 3.272 to 8. And there's two ways to answer it. You can say at 3.272 it's not increasing, but after 3.272 it is. And at t equals 8, it's still increasing because R of t is greater than d of t. All right. Or you can use, so you don't have to write both of these, but you can pick your style. You can see, you'll find them using both styles in AP courses. So you don't have to write this both ways. Just pick one, and then be sure to explain your answers. Here's the important part: since R of t is greater than d of t, and you don't even have to write since. You just write R of t is greater than d of t. All right, and hopefully this is an easy one. What interval are we decreasing on? How about somebody else?
Be from 0 to 2. I mean, 3.27.
Yeah, nice. And should I include 0 at 0? Is it increasing or decreasing, or neither one?
Would you include 0?
Well, at 0, is one higher than the other, or are they both? No.
They're both.
Yeah, so I don't want to include 0. At 0, we're neither increasing nor decreasing. But after t equals 0, yeah, we're decreasing. So 0 to 3.272, or again, you could write it this way: 0 is less than t is less than 3.272, and it's because d of t is greater than R of t. God bless you.
Thank you.
How do people feel about this one?
Why is it not t is less than or equal to?
Okay, because at 0 and at 3.272, R of t and d of t are equal, right? So we can only say the amount of water in the pipe is decreasing if d is greater than R. And we can only say it's increasing if R is greater than d. If they're equal, then it's kind of at a standstill. Does that make sense?
Yes.
Good. All right. So, let's let's do one more thing, and I'm going to get you guys out of here a little bit early today. I gave you a pretty heavy dose of homework tonight, so I'll try to make up for it by letting you go a little. But tonight's homework, it's another what we call rate in, rate out problem. It's a problem about snow is falling and somebody's shoveling the snow off of her driveway. So the snow's coming in at a certain rate and she's shoveling it off at a certain rate. But there's to complicate it, there's a piecewise defined function. So the rates change depending on what time of day it is. So it's a good challenge. And then I have 2 pages of review for you on tonight's homework also. Something that I just wanted to throw in here real quick. Let me get my act together here. Let's see. Okay.
Something is wrong. Don't like this. Your leg on brakes, not supposed to be how go slower. Press brake,
Okay, all right. Let me add a new page here. Here's something I don't think I put on the review. I'm going to put one of these, though, on your final exam. We haven't had it on any tests, but can you give me an exponential function? Write an equation in the form y equals a times b to the x to fit these 2 points. How about -2 comma 160 and how about +2 comma 6250. All right. Let's just talk about this one together. Who remembers how to get started if I want to come up with an exponential function that contains these 2 points?
You substitute them in for x and y.
Okay. Which one do you want to start with, Mark? The -2 comma 160 or the 2 comma 6250?
-2 comma 160.
All right. So 160 equals a b to the -2. And then we're going to substitute the other values, right? 6,250 equals ab squared. And what do we do with the 2 equations? Anybody?
You divide them.
I divide them. Good. So we're going to divide and use a fraction if it helps. 160 divided by 6250, 0.0256. I'm going to hit math, enter, and turn that into a fraction. 16 over 625 equals, and how about somebody besides Mark? What's b to the -2 divided by b to the +2?
1, because it's going to be b to the 0.
Okay, if you were multiplying, you'd be correct. Because you add exponents if you're multiplying.
Oh, you subtract. So it's -2 minus 2.
Good.
And then that's -4.
Perfect. So b to the -4. And there's a couple of ways I could go. I could flip both sides over. I could say b to the +4 equals 625 over 16. Or I can just go ahead now. I can use an exponent to cancel an exponent. How about a third person? What exponent can I use to cancel out that exponent of -4? Okay, if I was adding exponents, yeah, that would work. But remember when I raise a power to a power, I'm multiplying exponents. So -4 times what will turn it into a 1?
Square root to the 4th.
Okay, so yeah, 4th root would be the same thing. But I want to use the reciprocal of -4, -1/4.
Oh yeah.
Yeah, so what I could do, you know, I could turn it into b to the 4th equals 624 over 16, and then b is the 4th root of 624 over 16. Same thing as 625 over 16 to the 1/4. But anyways, this is going to give me, well, let me let you guys give it. What is 16 over 625 to the -1/4 power? So flip it over and take the 4th root. Or just use your calculator.
5?
What is it?
Is it 4 over 5?
Well, it would be 5 on top, though, and 2 on the bottom. If you're putting in a calculator, don't forget you need both of these fractions to be in parentheses. So that would give us our b. And now we want to plug into one of these equations and use it to find a. Does anybody have a preference? Should I use the 160 equals or the 6250 equals?
Mm, 160.
Okay. So now I'm going to go up here, plug it into this equation. So 160 equals a times 5/2 to the negative 2. And if I was going to finish this by hand, I'd say, well, that's a times 4/25, and then I would just multiply both sides by 25/4. But you can also just, divide both sides by 5/2 to the negative 2, and as long as you're using parentheses here, plug it into a calculator and you're good. But if I'm doing it by hand, it's 160 divided by 4, which is 40. 40 times 25, well, that's 4 times 25 with an extra 0.
1,000.
So that's 1,000. And then we would put it all together for a final answer. Y equals 1,000 times 5/2 to the x power. All right. So I hope you guys will, put some time into this AP-based problem that I'm giving you for homework, because it's the more experience you have with these, the less intimidating they are when you come to actually taking your AP calculus test. And obviously, the 2 pages of review for the final are important too. So I hope you guys have a great day, and stick around if you have any questions or comments. Otherwise, I'll see you tomorrow.
Bye. Have a good day.
You too. Thanks. Yeah. See ya.
I have a question concerning F for the AP question.
Okay. Let's go back to it. Let me share the screen with you again. Okay.
Bye-bye.
See you, Ramon. Have a great day.
I'll see you tomorrow.
All right.